Thanks, Angelica. Hey, everyone. My name is Tristan Ahmadi. I'm a solutions architect here with ClickHouse. Previously, I built mission critical systems for the federal government, where I was based out in DC. But since then, I've moved out west. I'm on the commercial team here at ClickHouse. So nice to meet everyone. I hope you get a lot out of the session, and thank you for taking time out of your day to join. We're going to be talking about ClickStack and how it really gets used for observability. As you can see from this slide, ClickHouse is widely used by several large and small companies for observability. As you can see, a lot of them are household names. If you're more interested, we can drop a link in the chat here at the end that goes through a lot of the videos from these actual companies, so you can better understand, what ClickHouse is doing with Tesla, what we're doing with Anthropic, Microsoft, Netflix, OpenAI. A lot of them have blogs that we've created, as well as videos from the actual, from the companies themselves, speaking about, their migration path, the reasons why they chose ClickHouse, what they're working on today, a little bit more about their observability use case, things like that. So we'll give you a link here at the end. But I think it might be helpful to go through a little bit of a history as to how some of these companies migrated to ClickHouse. And really that comes with understanding a little bit of history of observability itself. In its earlier form, from a search perspective, there was grep, right? Historically, this was used to search text files on any individual server, right? Eventually, that was used to search through logs. And the data wasn't organized, and it got more and more difficult as there were, more and more servers that you had to grep, across different files. Logs were getting larger, and there was really a need to be able to centralize and unify these logs into some sort of, let's call it a log aggregation platform. Splunk is an example of this. It's not necessarily the only one that grew in its time, but it was a means of being able to get all the logs in one place, across all the several different servers, across like growing volume. It was a way of being able to aggregate it. This was at a time when log volume was still light, right? When we say a lot was measured in hundreds of gigs or terabytes of data, and that was considered large volume. But it had the ability to scale, except that it came with a cost that was eventually prohibitive over time, and customers were thinking through how to move to different systems. And Elastic, grew in the 2010s from its open source roots. Again, definitely not the only one, but an example we'll use here, where Elastic specifically like grew from its roots in keyword search, and it was poised well to be able to handle log search really well, because you could search through error logs, you could search through stack traces, things like that. And it was a cheaper alternative to Splunk for a while. But it wasn't enough in terms of being able to find specific errors or logs across larger trends of data. When you were looking at lots of different servers, if you were looking across lots of different data centers, across different regions, being able to handle aggregations across all of these datas, search very well, right? It's a search engine, would always use it for that. But being able to do the other things that come with observability, like aggregations, things like that, it became a little bit difficult. But when you're starting to look at trends over servers, over data centers, over regions, you start looking at databases that were more time series oriented or metrics oriented, like Graphite. And there were then servers, they gained a lot more complexity. This brought in the need for systems and tools like Prometheus, which kind of grew as sort of a standard from a metrics perspective over time. It handled better support for high cardinality, being able to use labels in order to accommodate that. And then there were later tools like Thanos, continuing to be able to sort of handle that challenge and issue of scale, and being able to handle like cloud native diversity. But the problem is there's an increasing volume as we're going through these different systems, and what we're essentially doing is replacing one tool with another in order to handle the larger volume, handle the larger scale. And as you do so, you continue to make these sort of trade-offs. On one side, we've got search engines. On the other side, we've got metric stores. And search engines, were essentially great because you're able to find that needle in a haystack. But it got difficult as you started zooming out and aggregating across, all of what was happening. So now that you're starting to look at sum of, or percentiles of, or averages, it got more difficult. On the other hand, metric stores were great at that. They're good for pre-aggregation of data, But as you start to zoom in and deep dive into identification of a root cause, it got to be very difficult. So the challenge here is that we're looking for a perfect sort of intersection between being able to have the need for really good performance search, the ability to do fast aggregations, and the ability to do all of this in a cost efficient way. Wouldn't it, why not take advantage of cheap object storage that's available on cloud, while still giving users that blazing fast performance that they expect for pre-aggregated and ad hoc searches alike. There is a way to accomplish this, and ClickHouse is actually an incredible database for observability. It's a high-performance column-oriented SQL database. It handles lightweight indexes for search, so you're still able to find that needle in a haystack without taking up too much storage. It's also great at handling aggregations for billions of records, right, without requiring low cardinality pre-aggregated metrics, as is the case with a lot of those metric stores that we were looking at. And the fact that it's using object storage, as its backend, really you can handle infinite storage, essentially, and retention, being able to do so in a very cost-efficient way with the use of that object storage. So for those who aren't familiar with ClickHouse, it's a great database that covers a lot of different use cases from real-time analytics to OLAP data warehousing, but it comes with a lot of specific features that make it very well suited for observability as well. And I think that's why a lot of those enterprises and logos that we were looking at earlier are starting to realize this. With a separation of compute and storage, it offers that perfect mix of performance and cost efficiency, allowing it really to use, we talked about object storage as the back end, with scalable compute resources to help meet your observability needs. Whereas compute isolation, on the other hand, you can see that block on the bottom right corner, is allowing you to handle petabyte scale with real-time results for high ingest throughput, as well as the high concurrency queries. Okay, we accomplish this by splitting out and isolating dedicated compute resources for reads versus writes. And you can get creative and essentially allow yourself to do this for reads versus reads as well. Maybe you've got a certain set of compute resources for dashboards and another set for ad hoc queries and so forth. You get the idea. It's incredibly resource efficient, so really high compression ratios to reduce the overall hardware footprint, not just from a storage perspective, but from a compute resource perspective as well. It also allows for schemaless data, so you can just dump all of your, semi-structured JSON data. Very often there are situations where developers might want to just write arbitrary data properties, and ClickHouse supports that and allows you to query it as if it's just semi-structured data. We'll talk a little bit more about that in a second. It's easy to learn and very flexible, since it's ANSI SQL compliant. So it offers not only an easy learning curve for new users, since they typically come with a bit of SQL experience, but it's also flexible and allows you to integrate into your existing systems very well. So speaking to that point around compatibility, it also comes with a lot of different source and destination system integrations as well. OpenTelemetry is an example of that, but definitely not the only one. And it's interoperable with different storage standards as well. Data lakes like Parquet, Iceberg, Delta Lake. ClickHouse offers you the ability to work with those systems as well, not just from an ingest perspective, but also an interoperability to search across Glue or Unity catalogs as well. And to make it really easy to get started with all this, we've released ClickStack. So ClickHouse is a high-performance open source observability stack that's made up of OpenTelemetry, ClickHouse, and HyperDX. Let's talk about each of those. So OpenTelemetry, which has really quickly grown as a standard in the ability to collect and ship logs, metrics, traces. ClickHouse as the database itself. We talked a little bit about the advantages of ClickHouse on its own, and HyperDX as a visualization with the ability to do deep investigations and allow you to analyze dashboards, be able to perform all of your search capabilities and alerting from HyperDX as well. And it's all built and maintained here at ClickHouse by the makers of ClickHouse and HyperDX. So that's an important point because you are getting the best from an engineering perspective around the entire stack being able to be built by the makers and creators of these different systems. It works on its own if you're just getting started, or very conveniently on top of your existing ClickHouse database as well. So if you're already using ClickHouse, the stack can just sit right on top of that existing database, your existing cluster, to help brand out the end-to-end solution, offering the ingest and output from a visualization perspective as well. It's purpose-built for observability with the ability to monitor both, front end to infrastructure, whether you're, from a front end perspective, looking at the session replays to be able to identify how the experience looked from an end user perspective, all the way back to the infrastructure metrics view as well. And OpenTelemetry is a native that is, you know, eh, open source at its roots. So being able to incorporate that open source standard into ClickHouse just makes it all that much easier to and flexible to work with. We've covered a bit here on slides, so I want to take a break and just jump into a quick demo so you can understand what this looks like from a HyperDX perspective. So once deployed, we're going to look at what HyperDX looks like interacting with a backend ClickHouse database where we are collecting and ingesting OpenTelemetry logs and metrics and traces live. So let's take a look at that. Let me know if you're having issues seeing this, Angelica, but I think you should probably be able to see my screen where I'm right in on a view of HyperDX. Let me just
Looks
move
great.
this out of the way. Shrink that. Hopefully you can still see my screen. But this landing page is a really easy and familiar view for many people who have used different systems like this before. I see a histogram of all of my logs. And right now I'm looking at a live tail. So you're going to see things, my hands are off the keyboard. You're going to see a very sort of live refresh that's coming through, tailing my logs. And I've got some filters on the left that allow me to look at different parameters. I have a search bar at the very top. I can look at this from, Lucene or SQL as well. Lucene, if I want to have a more flexible, very, English-like, communication in terms of, hey, just show me all of the logs for this. SQL, if I want to be a little bit more specific and say, hey, I want to look at a specific, range of IP addresses within a specific data center at a specific time, and I know exactly how to craft that using a where clause. You can use SQL to accomplish that as well. I can look at different data sets that I might have. I'm looking at a specific demo data set for this example. But as part of a workflow example that we're going to do here, typically analysts are in situations where they're performing a retrospective or they are looking at sort of like an issue that may have taken place over the course of the last few hours, few days, and they want to better understand exactly what's happening or what happened. And this might be an example where they want to identify the reason for a lot of errors that were coming in. So I have the ability to look at specific severity text, and I can filter on errors. So again, I'll go ahead and click on that, and I see all of the errors. I'm still looking at a live tail view. So let's look back at maybe the last 12 hours and start there. I see them kind of spread out over a longer period of time. Let's go back and look at the last day. And now I'm starting to see that those errors kind of chunked within a specific point in time. And this makes it a little easier for me to pinpoint exactly when it happened. So that's really good. But I'm still in a situation where I have to scroll through and try to identify that root cause and what the sort of meaning behind this error was. And it's a little all over the place. I'm seeing a little of everything. But this is sort of where traditionally people were just kind of scanning and scrolling and spending a lot of time, potentially hours, trying to dig into what happened. HyperDX is very flexible here because it allows me to do an event pattern analysis mode, which is essentially telling the system, hey, group all of the very similar, sort of messages or log messages from an error perspective within the time range that I've specified here together, and just group them together for me so that I don't have to read through these. So if I click on that, I'm still looking at the same time range. I still see that cluster that I knew about, but now it's actually grouped together all of those patterns together so that I can see 22,000, some odd of these top five, and then the long tail thereafter that maybe I'm less interested in for this time range. But these top five are ones that are of interest to me. I see, some messages around unknown description, visa cache full replacing again, Failed to place order, not too descriptive, can't really tell much for that. And then I also see Visa cash flow mentioned in this other one. So there's sort of a pattern here, even across these five separate ones. They're all kind of saying the same thing. So from here, we'll dive into this. I'll click on that, and it's saying, hey, first off, let me just show you all of the instances that I grouped together, so I can see exactly when they were coming in, what records they were coming in for. We'll dive into any individual one of these right here, and we get a full original event view. Obviously, I could have clicked on any one of those, but it's going to be the same idea. When we do so, we get some good information right off the bat in terms of what the attributes associated with this were. But the real advantage here from a HyperDX perspective is pivoting from the log that I just looked at to the trace view. And now this trace view is going to allow me to see the full sort of surrounding context in terms of how this error took place. And I can see how it originated from a load generator that we have set up in order to load the data, how it affected the front end, and ultimately how this resulted in impacted the checkout experience from a service perspective as well. So this sort of cascading effect, I can kind of dig into this. I can also scroll down and better understand the resources associated with it. And if I wanted to get additional surrounding context, I can go ahead and click on that to understand what led to and what resulted from, that error. And it looks like I'm seeing things based on that cache being full. It prevented individuals from being able to ultimately complete their checkout experience. I can see cart errors associated with the checkout experience. So this is telling me, the cache being full resulted in an issue that affected my users, potentially affected sales. We can work with other teams to do a postmortem on how much, from a dollar loss perspective, this resulted in. While we're here, though, we can also dive into the metric view as well. We talked earlier about how we can, look at all layers of this. We started with logs, we're digging into the traces, but we can also take a look at the metrics view just to understand whether or not, hardware played a factor into this. From a pod view, looking at the last 30 minutes, let's look at the last hour. I can really quickly, you can see I'm not waiting as I click on each one of these buttons. This is pulling up really quickly, all because we're using ClickHouse under the covers here. But this is a really good view that's going to allow me to see from a CPU resource perspective, as I drag this over to the right, was there a correlating memory or disk issue associated with that as well? At the pod view, I'm not seeing that, so that's really good to see. I can do the same thing from a node perspective, being able to understand, as CPU, in this case, it was dropping. If it was spiking and holding high, I'd want to better understand exactly what was happening there. But you get the idea. This is sort of my ability and view in terms of being able to understand what's happening on the back end at the same time that this error was occurring. So very helpful view there. Another workflow that I think is really helpful to show is some of what the front end view of this might be. We're also able to do session replays. Monitoring that allows me to look at the user activity to see essentially what they were seeing. So if I look at client sessions, I can see individual user logins here. I'll click on any one of these, and I'm able to identify the network request made from the browser, trace it back to the back end, and see all of the traces around that. So you can see exactly how they navigated, scroll, clicks, things like that. I'm going to go ahead and perform a play of this session. Again, my hands are off the keyboard, so you can see nothing up my sleeves. Essentially, what this is doing is showing me the navigational path of the user, where they may have encountered the issue. So if you really wanted to get specific around what that error looked like from the user's perspective, we can kind of simulate that here as well. I'm not going to let this play all the way, but you get the idea. You can uh, kind of get a replay of exactly how that occurred and how maybe that might have been different for different users from different regions, from different locations, things like that. All right, I'm gonna pop on back out of here, jump back into my slides, and jump into presentation mode real quick here. And I want to talk a little bit about what's new to, observability as a whole, but specifically, within the context of ClickStack, what we're talking about here today. And I think one of the biggest things that we're really excited about is our new JSON data type support. To give a little bit of history, if you've used ClickHouse before, you know that we've always had the concept and ability to store map data types, which were, the ability and means of being able to store arbitrary keys, key values, which were really good for wide events and structured logging. You don't have to specify every property that's in the schema. And you can see here how it was defined. So specific resource attributes, we were using a map, and this was a string to string, and for the key value pair. But it came with some shortcomings. And really, one of the biggest ones was that there was a lot of wasted IO that resulted in this. Because essentially, it would have to read all of the keys before returning any result set back. And for hundreds or thousands of records, that's not too bad. But with some of those logos that you were seeing at the beginning of the slide, as data volume increases to that scale, as you can imagine, this really adds up. So this puts us in a position where all of that wasted IO results in poor performance and cost issues as well because of the resources required to power that IO. A second one is a loss in precision, right? Casting it all as a string puts us in a situation where we lose precision because then you'll have to cast it back to a float or integer if you're looking to perform any level of aggregation around it. It's possible, but it requires extra work. So, you can only do so much with a string, and that was an issue for a lot of the numerics. There was also no concept of data nesting. There was work that could be done. A lot of flattening had to be done in order to make the data usable, especially for very frequently used attributes, as you can imagine. So not being able to have that ability to do nesting presented a lot of challenges. Again, flattening the data out, it's possible. It was doable, but again, it was just an extra step that had to be done. So now with the new JSON data type, you can see how that's defined here. Very easy, no need to map anything. You're just specifying it as a JSON, and you're able to make things a lot easier and faster. I mean, it offers performance benefits as it was structured, like its structure was predefined schema, and giving you the flexibility to add arbitrary attributes as part of that as well. Um, Performance is one where uh, you're gaining a lot of benefits here by, you're storing an integer as an integer. You're able to store, a string as a string, and you're not having to cast those data types into a different format in order to be able to allow for aggregations or searches and so forth. It handled nesting structures very well as well. There was no need to flatten that data ahead of time. JSON is JSON, so you store it as is. And it automatically manages all of the properties being written as well. So, it recognizes the most important and the most often used, and being able to optimize them by turning them into a specific column on its own and putting them into bigger buckets if necessary as well. We'll talk a little bit about how that looks in the next slide. So, for example, every time you write an attribute into ClickHouse, it's being stored as its own column. So even if you have a property with multiple types, ClickHouse will handle that as well by detecting it and storing it as its own column. So integers are being, put into the same column. All of your floats are being put into the same column. And it's also handling that field explosion really well also. So you run into a situation where what if you have lots of columns? We talk to customers all the time where they're saying, yeah, but I have, thousands of columns, like how is it going to handle all of these different properties? And it's actually very intelligent in terms of how it does this because it's going to determine columns that make sense to be stored as its own column, and those that can gain a certain degree of efficiency by being grouped, like I just mentioned for all of your floats, all of your integers, things like that. So this keeps the database performant for your most commonly used while saving space for the rest. So you're getting the best of both worlds in that regard. That's everything from the JSON side. I'm excited about all that's being worked on from that regard, but there are a lot of other performance optimizations that are coming, as well. An example of that would be improvements in the way that we order the data in ClickHouse for scans. So whether you're looking for the oldest data first or the newest data first, this optimization allows ClickHouse to perform an in-order scan, essentially. So you can see in this example, this little demo that's being run, the original query, let's see, for it to run takes 1.9 seconds. And then the new version that we're running with the in-order scanning is basically taking a fraction of a second here. So incredibly fast performance by being able to rethink how we order the data optimized for scans. another mechanism how ClickHouse is so incredibly fast and performant at massive scale. Um, so, talking a little bit about how we chunk time ranges, if you look at a query that's, performing a select and doing a where on a large time range, that's actually getting chunked into smaller time ranges to be able to search them asynchronously. Because really, it's inefficient to look at a whole date range without prioritizing what part of that data to look at first, or second, or sort of like as it's going through. But this way, we can actually look at the latest or oldest data to prioritize that while we search through all of the data in order to reduce the query response time that's coming back as well. And we're excited to have ClickStack actually integrated right into ClickHouse Cloud as well. So for those of you that don't know, ClickHouse also manages and maintains ClickHouse Cloud, which is our fully managed SaaS platform. Allows you to get started with ClickHouse very easily, handles massive scale, offers that separation of compute and storage that we talked about. So if you're using ClickHouse Cloud today, now you can actually use the integration to launch an observability native experience right from your ClickHouse Cloud UI. So there's no need for a new account. You just click on the link on the left panel, and there's no need for additional connectivity, hooking into your endpoint. It's already built right into it. So just clicking that link as part of the private preview, that should be available in your cloud UI today. And there's a lot more that's coming. This shows sort of like a rough list of some of the things that are being worked on and that are coming soon. Being able to handle extensible collector configurations. We hear from lots of customers, hey, I just want to be able to export this to a CSV so that I can take the data elsewhere, being able to do that very easily. All auto-correlated results. So you saw some of the ease in my ability to go from, one specific large time frame, and be able to have the system grouped and just come to me with the insights and let me know, hey, this is the information that's most insightful. I'm noticing a pattern in the events that I've looked at. This is the biggest impact, right? Being able to continue down that path of delivering the insights to you, is all part of kind of what you're seeing here on this list. Having an inverted index support for keyword searches. It's coming in an experimental form here pretty soon. There's actually a waitlist page that you can subscribe if you want more information around this, if you want it enabled for your ClickHouse cluster. Happy to extend that to you. Please feel free to ask us in the chat more about it. The ability to import export dashboards, so making that interoperability between different systems. So if you've got users who are using HyperDX dashboards and you want to be able to migrate from one team to another, making it really easy to do that as well. Pinning filter fields, so if you're commonly reusing them and you want to just be able to pin them to the top, that's going to make it easy to do so. A lot of flexibility with chart aggregations and aliases. PromQL support is something that is, as we talked about earlier, a very growing standard from a metric perspective. Being able to build and integrate PromQL support into HyperDX is something that we're looking forward to as well. Integrating this fully into ClickStack Cloud. So today it's downloadable from an open source perspective to run as a single Docker executable on your machine, on your server. So very easy to get started there, but being able to have a fully cloud native means of having this observability native experience with ClickHouse as the back end, all of that coming as well. We talked a little bit about the inverted index, but things like observability notebooks, service map, right, really extending that view within HyperDX to be able to get start lodge and drill into the root cause analysis very quickly, making all of this easy to manage from a Terraform perspective as well, and so much more. So I'm excited about not only how far along the product has come in a short period of time, but the work that the team is putting into this. I see that Dale just joined. Dale, we're just kind of talking through some of the future of what's coming. But that's everything I've got here today. Please feel free to get started. This link, clickhouse.com/Ali O11Y will take you right to the getting started experience for ClickStack, how you can get started with ClickStack from a open source perspective, as well as ClickHouse Cloud as well. So I'll stop there. Thank you all for your time. Maybe this is a good time to dive right into questions and hear from the audience.
Hey Tristan. Yeah, I see there's a few. I only see the questions after I joined, unfortunately. So if you've got the full chat and you're able to read them out, that would be great. I see the last one, which is what are observability notebooks? So that might be worth just explaining what we're thinking about there. So there will be an experience inside the UI, HyperDX, where you're able to do effectively, if you can imagine like a Pythonic notebook experience, but not writing Python. Instead, you're writing SQL queries. Maybe you can also write some Python there. And you're able to, and it's very much a chat-like interface. So there will be some sort of AI angle to that. So if any of you've used LibreChat, for example, that would probably be a component of that in terms of being able to have a conversation as part of that notebook. And then we anticipate having some form of branching experience inside that. So if you decide that the response isn't quite good enough, or you decide that you want to take the notebook in a slightly different direction, you can branch off. I think we'll have early demos, probably, hopefully at KubeCon next week if people are around. So if they are attending, but we'll do some announcements post KubeCon for people that are interested. So it's imminent. We don't want to share too many details. We want it to be a surprise, but hopefully that gives people an idea of what we mean by observability notebooks. And those notebooks would be savable and maybe even convertible into runbooks once you've established something that's useful. So I see. So that was answered. So how would this compare to say Datadog or SolarWinds? So SolarWinds is quite old, powered by ClickHouse actually. But Datadog is a full SaaS offering for an observability solution. At this point, ClickStack is more comparable to something like the Elk stack. So that's probably it's more of an open source stack that you can run. But we will also run the compute for you in ClickHouse Cloud. So if you don't want to run the compute element of it. And now it's probably not the breadth of features, it's probably not as broad as Datadog. Datadog has been around for a very long time. I would say principally we focus on high density, high volume, specifically high volume OpenTelemetry, preferably. It doesn't have to be, but we prefer high volume OpenTelemetry. So we would say OpenTelemetry at scale, logs, principally APM traces, classic tracing, and then RUM. The other use cases we wouldn't be really have like a dedicated UI offering, although you could store the data in ClickHouse if you wanted to. But we don't have, for example, like a profiling UI like Datadog. So hopefully that gives you some idea in terms of like if you were to use ClickHouse Cloud, you'd be paying for just the compute that you use versus having all the SKUs that these observability SaaS offerings have. So that does allow you to be more cost efficient. Hopefully that answers that one. Tristan?
Yeah, so question from somebody asking around some of the other use cases that we support around how ClickHouse can be used as an MCP server for integration with AI. Yeah, so if for those who are not aware, as I mentioned earlier, ClickHouse gets used for a lot of different use cases, real-time analytics for a lot of customer-facing sort of dashboards, customer-facing analytics for SaaS systems that that our own customers are building, machine learning and agentic AI experiences that are being built into some of these systems is another one. So ClickHouse has released its own official MCP server for integration with the backend database itself. An example of how this might be used to the point of your question would be allowing a user to come in and hit some sort of, UI, whether it's something open source like LibreChat, whether it's something that they've built themselves, some sort of like native chatbot experience that's going to communicate between the LLM for the contextual awareness of the question, as well as the actual data itself that's stored in ClickHouse. In order to be able to achieve that, you need an MCP server as the bridge in between the LLM as well as the database. So the MCP is going to do all of the rights management. It's going to do all of the conversion into SQL that ClickHouse is going to understand. And you know that the SQL is going to be, high quality because it's purpose built for ClickHouse by ClickHouse. So that MCP server integration is something we're really excited about. I see it getting used from two perspectives. From the real-time analytics perspective, we're going to have our own customers building platforms that are going to allow their SaaS-based customers to, ask questions about their data, like, where are my customers coming from? Just having this sort of like native English, like natural language, communication with their system. From an observability perspective, it's going to allow us to load logs, metrics, traces into the backend ClickHouse and allow the MCP server to integrate with LLM where I can just, you saw me go through a workflow earlier of identifying the root cause of errors that took place in the past day. That would be a situation where I would just ask the question, hey, why did these errors come up between the last 12 hours or within the last day? And that result should just come back to me, in a summarized fashion, along with potentially some dashboards and views from a resource perspective that I can take right into a conference that I can share with my team as part of a postmortem or triage effort. I'll stop there. I think we've got a couple questions for you, Dale, if you want to
Yeah,
field
I'll
them.
take it. It might be just worth noting that we've literally just announced that LibreChat have joined ClickHouse. So if you are aware of what LibreChat is as a chat interface for an equivalent of like the OpenAI chat interface, that's now part of ClickHouse as well. So we will be tightly integrating that into the stack. Yeah, so will PromQL be supported by ClickHouse or translated to SQL by HyperDX? PromQL will be supported by ClickHouse. It's in version 24.9. We have the first iteration of it. So 24.10 coverage is improving. You can expect us to, and it will be an open source ClickHouse. Coverage for PromQL improvements will come every month. The coverage right now for the full PromQL suite of tests is pretty low, but we like to release things iteratively month over month, so we expect that to improve pretty quickly. So, and then once it gets to a level of maturity that we're happy with, we'll just expose PromQL in the ClickStack UI. HyperDX ClickStack is cloud only. No, it's open source. You can download it and run it yourself. The ClickHouse is obviously Apache 2. HyperDX UI is MIT, which is even more permissive, I think, than Apache 2. And our distribution of the OpenTelemetry collector is also Apache 2. So all downloadable and run yourself. Um, how to deal with, so really impressive to see OpenAI and Anthropic on your customer list. Can you talk about how they're using ClickStack today? OpenAI, both of them are logging use cases. Both of them are there's customer stories on our websites for both of them. Thanks for posting those. I would say Anthropic have provided us with a lot of feedback on the HyperDX UI, especially at their scale, which is pretty unique. So they're working with us to improve the UI experience. There's even, you can imagine when you're running with the order that they're running at, even a one rogue SQL query that hasn't been thought necessarily through in the UI can slow down the whole experience. So we appreciate their feedback. How to deal with conflicting JSON types when a JSON field comes as an integer and then later as a string. ClickHouse handles that automatically. It creates two separate subcolumns, one for the integer, one for the string, and then at query time they can be cast. We don't, other data stores may just infer the first type that they see. We don't. We create subcolumns for every single one, and then they can be cast at query time using standard query operations. Hopefully that answers that one, Robert. Can you explain? Okay, so the MCP stuff. Thanks, Tristan. Can you explain what you mean by index templates and data retention times in S3? Is there a template for applying to specific types of data? Um, so you can apply DDL statements on the end of a table to say how long data should be retained, after which it should be expired. You can also apply that at a column level. So you can say after this amount of time, and just next to the column definition, you put DDL and you put an expiration time relative to a timestamp on the table. I would defer people to look at the docs on that. If you look for DDLs, ClickHouse, you should find everything that you need. How about authorization to enable roles, to enable permissions on the stored data? And if can the authorization be retrieved from data in OIDC? No. So today we don't have RBAC inside HyperDX. It's done at the database level. Actively working on now to unify that into the UI such that RBAC permissions at the database will be reflected in the user interface. That's probably our biggest priority task, aside from some alerting stuff, which we'll announce this week. Tristan, we've answered that one. Do you plan to add a feature that will allow using HyperDX dashboards to visualize data that's not related to logs, traces, or metrics, or from a ClickHouse cluster? Yeah, you can use any data you want. Just like, I mean, you get a lot of talk in observability about wide events where people just like put lots of metrics on a column, and all you need is a timestamp. Just visualize them as logs. It's maybe we should have a separate data source type, which is like events. But effectively, for logs, all you need to specify is a timestamp for that source, and you can just visualize them like any other event. So you're not restricted to just the OpenTelemetry schema. You can use any schema you like. Are there any agents I can install in my app to speed development? A host-based agent on Linux or say a jar I can drop into my application? Yeah, so if you look for ClickStack SDKs, you'll find all the SDKs that we provide for the different languages. They're all forks of the OpenTelemetry ones. In a few cases, they are not, there's very little minimal difference. And we are always compatible with the OpenTelemetry SDKs. The ones which are significantly different are the Node.js and the JavaScript one. The JavaScript one is really significantly different because it captures session replays to allow you to see what the user experienced in the browser and actually replay their session. I don't know if we showed that feature, Tristan, but that JavaScript agent, like if you think of that like a full story or session replay capabilities that you may have seen in other stacks, we support that, and that's done it. That information is collected by the JavaScript agent because it collects events in the browser. So that's the one that's significantly different. The others, varying degrees, but I would just say in many cases you can use the OpenTelemetry SDK if you're already using it. I think that's everything. Is that everything?
I think it is. Yeah, Dale, thanks so much for your expertise here. Appreciate having you here to join us to answer some questions. And as I said earlier, thank you all. Thank you to all the participants who joined as well. It's hard taking time out of our work days to join sessions like this. So, we really appreciate it. Hopefully you gain something from it.